Chapter 9, Lesson 7, Systems of Linear and Quadratic Equations. So what we're going to be doing today is we're going to be solving for the intersection of a line and a parabola. So we're going to have three options. The first option would be the line crosses your parabola in two places. The second option would be that your line would only just maybe touch the corner or the bottom of your parabola. And the last option would be if you graphed both the parabola and the line and they did not cross. It's like a no solution. So what we're going to make sure is each equation in y equals form. We're going to graph the table of values for the linear, and we're going to do the quadratic by using our axis symmetry, our vertex, and our intercepts. And then we're going to find their intersection points. And actually, we're not going to use the table of values for the linear. We're just going to graph them by slope-intercept form. So here's my linear. It starts at 1, and the slope is down 1 over 1. Then for my quadratic, there is no b term, so my axis of symmetry is going to be at x equals 0 over 2 times 1, which is 0. Then my vertex, I'm going to put 0 back in, and that would give me negative 1. Then I'm going to solve it to figure out what my intercepts were. So I'm going to add 1 to both sides and then take the square root. And there is my parabola. So I know for sure that one of my intersection points is right here at 1, 0. And my second one looks to be at negative 2, 3. But I'm going to check that one on my calculator. So if I go to my y equals on my calculator and put x squared minus 1 into my first one and negative x plus 1 into my y2, it will look like, where's my, oh, there it is. I don't know how to tell if this is still recording the screen I was on. I'm just going to do it in decimals just to make sure. To change it, Shift Alt F. All right, so we have y equals x squared minus 1 and y equals negative x plus 1. And so you can see that we did guess right. The other one is at negative 2, 3, and the other one is at 1, 0. And if you would have graphed it in your graphing calculator, which I don't know if you can see, I'll just go ahead and screenshot and then hopefully you can see. And you do second trace and go down to number 5, which says intersect. And that should give you your 2 intersection points. Okay, so we'll do the same thing on this next one. My linear equation starts at negative 1 and the slope is up 2 over 1. My quadratic has an axis of symmetry at negative 1 over 2 times 1, which is negative half. And then when I put that back in, I do negative half squared plus negative half minus 3. It's at negative 3.25. And then when I solve it, looking for factors of 3 that subtract to be 1, there aren't any. So I cannot find, well, there's decimals. So I can't find my x-intercepts, but I could find my y-intercept at -3. So if I had to guess, my one intercept would be at -1, -3. And my other intercept, I would guess to be at +½ -½ But again, we'll check the decimals and see what that says. X squared plus 1x minus 3. And the other one was 2x. No, it was 2x minus 1. Alt Shift F. Oh, so I was way off. I did get that one -1, -3. My other one I was way off. Should be at 2, 3. All right, so since that's not very reliable, what we can actually do is solve for the intersection of the line and the parabola algebraically. So here, number 1, I'm going to set this bottom equation as -1x minus 3, and then sub that in for the y. So my equation is going to be x squared minus 4x minus 1 equal to -1x minus 3. Add 1x to both sides, and add 3. How about if I added 1x correctly? Oops. It should be added 1x would be -3x. So then when I go to solve, this is not a window method. It's just 2 and 1. Sign chart is both minus. And so this one, the first point they should cross at is 1 comma something. And the second place they cross at is 2 comma something. So to figure those out, I can put them into either equation. So I'm going to choose to put them into the first equation. And that would give me -4 and -5. So we should have them crossing at 1 comma -4 and 2 comma -5. X squared minus 4x minus 1 and -1x minus 3. So here we have this point was at 1 -4 and the second point at 2 -5. On the second one, I'll do the same thing for number 6. I'm going to substitute this in here. So I have x squared plus 3x minus 1 equals -1x minus 3. Going to add 1x to both sides and also add 3. This one's looking for factors of 2 that add up to 4, and there are none. So this one should be a no solution or no intersection. X squared plus 3x minus 1. And -x minus 3. Minus 5, whoops. This one shows they should have one solution. It's at -2, -3. Oh, that's because I wrote this one down as a 3. This was supposed to be a 5, right? Oops. Oh, yes. Okay. So if I change that to a 5 and change this then to a 4, so factors of 4 that add up to 4 are 2 and 2. Sign chart says both plus. So that would make this first one, and both of them actually at a -2, comma, and if I put that back up into this first equation, -3. And that's what this one is showing, a 1 solution. Okay, on the last one, the first thing I'm going to start with is adding 2x to both sides. And this bottom one needs to subtract 4. So that would give me x squared plus 2x equals 1x minus 4. So x squared plus 1x plus 4 equals 0. And this time there are no factors of 4 that add up to 1. So this one for sure should be a no solution. So y equals x squared plus 2x. And y equals 1x minus 4. And if you look here, they do not cross, so there is no solution. The quadratic graph represents the height of a soccer ball kicked. The linear graph represents the height of the player's head who is running up to head it into the net. At what height will the player's head contact the ball? So we want to find this intersection point here, which is at a height of 8 feet. The monthly expenses of a business can be modeled by y equals 2.75x plus 7.5. The revenue generated by the business can be represented by the second function. After how many months would the revenue earned be equal to the business expenses? So I know I want to set these two equal to each other using substitution. So I'm going to have 0.2x squared plus 1.5x equals 2.75x plus 7.5. So 0.2x squared, 1.5 minus 2.75 is negative 1.25. On this one, I don't want to try to factor because it looks really sloppy. I'm actually just going to use the quadratic formula. So this is A, this is B, and this is C. So we do the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2A. So parenthesis 1.25 plus the square root of 1.25 squared minus 4 times 0.2 times negative 7.5. Arrow out, close, divided by open, 2 times 0.2 is, so the first one I got 10, and the second one I got negative 3.75. So this is the only one that makes sense. So after how many months will they be equal? After 10 months.